the basic features of every exponential graph. We're now studying the basic features of a log graph. To understand the log graph, you have to understand that the exponential function and the log function are inverses of one another. And therefore, the domain of the exponential is going to be the range of the log, and the range for the exponential is going to be the domain of the log. Note too that 0, 1, and 1b are the basic points for every exponential function, and that's reversed in the log function, and that would be 1, 0, base 1. Also too, the horizontal asymptote is at y equals 0 for the exponential, and therefore would be at x equals 0 for the log function, since they're inverses of one another. The basic log graph looks like this. These are examples of different logs with different bases. Note that they go through the ordered pair 1, 0, and the vertical asymptote is at x equals 0. Later we'll learn how to transform these graphs, but for now this is the basic look of the graph. On the note page is a script that will enable you to play with the exponential and the log, and it looks like this. If you note, this is the graph of the red graph is the graph of y equals e to the x, and the blue graph is the inverse, which would be the natural log of x. 0, 1, 1, 0, y equals 0, x equals 0 are the basic features for these graphs. And over here are sliders that you can manipulate to change the basic shape of the graph. I'll pull that in so you can see it. If you play around with the d value, that will raise, as you remember, the horizontal asymptote for the exponential, but it will be the inverse for the log, in that y equals 2 is the horizontal asymptote for this exponential, x equals 2 is the vertical for the log. And if you note that the ordered pair here is 3, 0, which would be 0, 3 here. Note too that since they're inverses, they are reflected over the line y equals x, as with all inverse functions. The range for this function is y is greater than 2, and therefore the domain of this log is restricted in that it has to be greater than 2, not inclusive. You can play around with these yourself. These will change the various shapes. Note how the relationship always maintains itself. As I enable a to be negative, you'll note the relationship is always maintains the reflection over the line y equals x. And same with b. If I make b negative, you'll see how it gets reflected over the y-axis, etc. And that's really basically it. Play around with it yourself and discover the relationships all on your own. Remember, ownership is the key to understanding all this stuff.